I am Sefin Ansar, student of Moscow Power Engineering Institute, Cathedra of Generation of Signals and Oscillations, and my project is fast locked loop systems with samples for multi-computing calculations, design of pseudo-random number generation, and frequency synthesis. Next. First of all, let's talk about phenomenon of synchronization. Next. Phenomenon of synchronization. You could see between two systems, controlling element and controllable element. Here we see example. Then our biological time, biological rhythm works simultaneously with geographic time. Next. Here we see the next example of phenomenon of synchronization. Here we see rhythm synchronization, then our sleeping, our temperature must be synchronized in our biology. For example, clock synchronization. Here we see synchronization in phase, in antiphase, and without synchronization. Next. Phenomenon of synchronization we could see in nature. For example, birds, fishes, synchronization in dancing, synchronization of telephone callings. Next. Here we see the following principle of synchronization. Then information between two objects, controlling element and controllable element, is exchanged discrete in time. For example, here we see two spices and secret information between them exchanged discrete in time. Next. Phenomenon of synchronization are widely used in a lot of technical applications. For example, in TV, then vertical and horizontal scans must work simultaneously. Then optical and laser synchronization. Then we see synchronization between high precision laser device and fast locked loop system, for example. Here we see synchronization in codes, synchronization between a lot of elements, a lot of multi-computing calculations, and here we see synchronization in large devices, in, for example, hydroelectric stations. Next. A phenomenon of synchronization widely used in space technologies and electronic and on the Earth navigation systems. Next. Now I present my project. My device is fast locked loop system with samples. Next. Standard scheme of frequency synthesis use input signal and generate a spectrum of output signals with fractional frequencies. In general, this problem solves using the following scheme, fast locked loop scheme. And here we see frequency divider 1, frequency divider 2, fast discriminator, loop filter, and voltage control oscillator. And this scheme generates oscillation with fractional frequencies. Next. My scheme, fast locked loop system with samples, consists of following blocks. Here we see pulse fast discriminator, voltage control oscillator, loop filter, and pulse generator. And next. And in this scheme we see a lot of physical zones of synchronization, a lot of locking regimes. in standard scheme, we saw only one block of synchronization, here red. But in this scheme, in this parallel scheme, we can see a lot of working regimes with fractional frequencies. Next. Here we see three pictures. The first picture is the map of synchronization zones using a harmonic input signal. Next, triangular form of input signal, and the next, more complicated input signal. This picture, we could see open map of synchronization zones in the picture of controlled parameter. Next. And now let's talk about applications of this fast lock loop system device. Next. This scheme could be used in organizing of multi-computing calculations. Here one signal, here blue, move through common data bus, and red signals goes to the processors or computers. And the problem here to synchronize these signals, and my device solve this problem. Next. Here we see synchronization principle to construct encoders. Here we see chaotic oscillation and main signal. And advantage of this device here is ease of implementation. Next. And now the last application is frequency synthesis. Here we see a lot of zones of fractional synthesis. And next, now some advantages. Here we see that this fast locked loop system with samples block is very easy of implementation. Absence of frequency division blocks, feasibility of chaotic regimes, flexible operating modes dependent on the choice of reference signals, possibility of frequency synthesis, division and multiplication, and decisions in one block of various technical problems. Next. Thank you for your attention.